Welcome to Explain It Like I'm 5, Hexadecimal Numbers. Hey, I'm Eric, and a recent discussion on LinkedIn, of all places, were about hexadecimal numbers and Business Central and how to work with them in Business Central. And there were some misunderstandings that got cleared up, and all is good, but I thought it would be a good topic for an ELI5 video, because some of the comments really showed that perhaps, and not surprisingly, hexadecimal knowledge on hexadecimal in general is perhaps not that widely known in the BC community. And why should it be? Because it's rarely used, but nonetheless sometimes it's used by different things, and especially now with keys and encryptions and stuff like that. So I thought let's do a quick primer video on hexadecimal numbers. Here is my Business Central. No, this is not my Business Central. This is just my Visual Studio Code. And let's just talk for one instance on how we represent numbers. So we, as humans, we love what is known as base 10. We got 10 fingers on our hands, so it's a very natural way of counting. So for every digit, so if we have a digit, well, we can do everything from 0 to 9 in a single spot. And if we need to do more, then we add a 1, which represents the tens, and then we put a 15 here, and now we use 2 digits to describe the number 15. And if we get up to 105, then we use 3 digits. Deep down in the computer, the lowest thing we have is a bit. We don't use that rarely, not at all. I don't think there's anywhere in Business Central where we're actually using bits. If we were on, let me switch over here, and you know, the computers from the olden days, each of these switches actually represent a bit, so the lowest thing. But bits are grouped together depending on how wide the data bus in your computer is, and typically nowadays it's 64-bit computers, but for a long time 8-bit was kind of the thing. So a byte, which is 8-bit, became a universal standard for characters and stuff like that, and storage. So whenever we talk about gigabytes or kilobytes or megabytes, it's always bytes, and a byte is 8 bits. So if I were to write the number 0 as binary, I would say 1 2 3 4 1 2 3 4, and this is 0 in binary. If I wanted to change this to a 1, I would say 1. If I were to change this into a 2, I would go to the 2-bit. So now you see, if we, and this is getting hard to actually show. Let's see if we can do this in a meaningful way without getting 2 4 8. Let's just use those. So we can see here that the least significant bit represents a 1. The next up represents a 2. So in order for us to write 2 in binary, we put a 1 here. If one were to write it 3, it would be 1 1, because 1 plus 2. If we were to write a 7, we would have 3 1s. If we were to write 15, we would have 4 1s. So if we look at, and this is so back in the olden days, well, I guess that's still the case. You kind of look at a byte of having 2 sections, the high nibble and the low nibble. So I don't know why it's called that. And they are each each representing by 4 bits. And this is great. So if we were to take these 4 bits and we want to describe them in a single character, so only using 1 character, well, at least we know that we cannot, we cannot write 15 in as 1. We don't have anything past 9 in base 10, right? So as soon as we want to write 15, we got to use 2 characters. But the hexadecimal, means 16, base 16, gives us the option. And since we are running out of actual characters, we invent some new ones, and we use letters for that. So in hexadecimal, in the hexadecimal world, we start by 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go to letters. So we have not an S, we have an A, B, C, D, E, F. Meaning that if we want to write the 15 we have here, we'll just write an F. If our number was 255, meaning from a binary perspective all ones, that will then be FF, written just as FF, meaning that now we have a 2-character representation of a single byte. So in something that's readable, we can write the value of a byte using 2 characters that exist on any keyboard, even something from the 70s or older. And so if we see something like, like this, we know that these are hexadecimal numbers and they are lined nicely. So quite often, when old geeks like me open a hex browser to look at stuff, we will see something like, something like this, and it's nicely organized. We know as soon as we see that these are the numbers, and we can see that because of this separation, right? So we have the 4 bits and the 4 bits. We can actually pretty quickly determine the bit pattern here. Meaning that if, let's say that the hexadecimal number is 22, and here is, you want to call that 22 so badly, but it's not 22, right? So the 2 up here, the first 2 are 2 times, so in order to translate, that's 2 times 16 plus 2. So this is 34 written as hex 22. But also we can quite easily figure out what is the bit pattern for this, because we just established that the bit pattern for a 2 was 10. So now we know that the bit pattern for this is 1101. So, well, did I say 1? 0010 and 0010. And if this is too confusing, if you're actually gonna work with this, even the calculator in Windows can do this stuff. So we can go here and say 34, and this requires us to select the programmer calculator, so we can see 34, and we can see that is hex 22, which is not hex 22 but the hex 22. Yeah, I'm doing it. It's very hard not to. And we can also see the binary representation here. I know it's very small in this one. If I click here, we can see that that's the binary. And I was nice enough to prefix the zeros. This one is not prefixing the zeros to pad to 8. So so let's actually see how we can work with hexadecimal in BC. So if you need to produce something in hexadecimal, how do you do that? And the easy explanation is that we have a code unit called a type helper. And there's even I know there's a video on the channel about the type helper code unit, like an overview of all the stuff that's in it. I suggest you subscribe and then go check that out after this video. So the type helper is kind of just a little utility code unit, and this one has a function hex % equal like this. So we can do, let's use 34 again. That's a good number. So in the type helper, there's a function called integer to hex, and we want to put 34 in. And the first question, why only? There's only integer to hex. But remember that a hexadecimal, there's no decimals. In hexadecimal, you don't say BC something F, comma 45F. Well, you kind of could, but since we're mainly using hexadecimal, we're only using hexadecimal to represent memory in a computer. We're not representing something as abstract to a computer as a decimal number. So I guess this could be a really evil math task, but I'll leave that up to you guys in comments if somebody want to do math in hexadecimal with decimals. Anyway, so it only makes sense to convert integer to hexadecimal. So let's see how this works. I'll just hit F5 and publish. And I need to log in because I've talked so long, probably. And hex 30. Oh, decimal 34 is equal. That was a bad message, but we recognize the numbers by now, I think. So let's change this just for, preserve this for the equal hex, something like that. What about 4? What about the number 4? Let's see how that goes. Publish again. We don't even have to log in. So hexadecimal 4 is equal hex 4. But remember, I was actually padding those when I wrote them. So if we were to create, and this was kind of the discussion on LinkedIn. Let's say we have an input. Wow. And an output. And then we need an integer to look through. So we have an input string called YouTube, for instance. And we want to convert that into a hexadecimal string. We could go and say, okay, for I equal, 1 to string length of input, do output incremented with type helper dot int to hex. And what is the int in this case? Because we have a string. Well, a string is actually a array of characters. In this case, we're actually Unicode. So I am now pretending that I am pretending that Business Central is 8-bit, which is not the case. But for the purpose of my test, everything I'm using here is within the 8-bit range of a Unicode character, which is 16-bit plus more. So I can do input and treat that as an array and use I. So I get a char back, and a char is the same as a byte. And let's get rid of this one and say message input equal %1, output equal %2, input comma output, and there we go. So now I am building up a string of the hex numbers here. And it looks like something went wrong. How about that? Let's see if we got an error. Let's see what that is. Unable to convert from system char to system int32. Microsoft is getting pretty lazy with their some of the error messages when they're calling the .NET sub thing. So we need to help this on its way a bit to figure out that the int32, that's an integer, and char was what we had. So let's help the type conversion on its way. We can do byte here actually, I think, and then begin end, and then let's say that byte equal input I. I think we'll run into the same issue, so let's just do integer. And then we'll pass the byte here instead. How about that? Let's see if that works. It worked. So now we have a 59 6F blah 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 blah. That's the YouTube letters as hexadecimal. The challenge we might run into is that, remember when it said 4 = 4 when we did this guy? So actually we have to say, okay, if b is less than 16, then we gotta pad the output with a 0. So in case of our input string here being all fake 8-bit characters, we won't get into the first 16 first 16 bytes of 16 places of the ASCII table, so we won't hit it. But if we were actually processing something truly binary, where we might have zeros, then we would need to pad this. And now I see that I have talked about hexadecimal numbers for 18 minutes. So I think that's probably a good place to stop. Where would you need to use hexadecimal numbers? Well, in some cases, if you have a piece of memory that you need to show, like you have a encryption key. An encryption key is 512 bits or 256 bits or something like that. The typical convention of exchanging something like that is as a hexadecimal string. So this is how you can create it. Then your input would not be a string, but it might be a stream or something else. And last comment here, and I'll try to actually wrap this up, is that base 64 encoding is something completely different. You know, now we know that because we have talked about base 10 and base 2 and base 16, but base 64 is a different animal. So base 64 means that we can represent 64 bits as one character. And that the idea behind that is basically, let's see if we can pack more information into something that will will be in clear text. So we have way more digits, because we have all the letters, and we have a couple of special characters and so on. So base 64 is not the same as hexadecimal. Hexadecimal is base 16, which is 16 is not 64. So those are completely different ways of expressing data. Anyway, I think that's it for this video. Let me know in the comments below if videos like this make sense, or I should just stay to the straight and narrow path of only Business Central. Let me know, and I'll see you again in the next video. Take care. Bye.